Okay, so we're looking at the check your understanding for 5.6 that you guys are supposed to complete. So here are the answers there. Here you're just plugging in 0 for x, 1 for x, 2 for x, and so on. And so then hopefully you could get those from that. Write an equation relating log base 2 of w with log base 8 of w. So they said log base 2 of w was equal to 3 times log base 8 of w, or log base 8 of w is 1/3 log base 2 of w. And that's really because 8 is equal to 2 to the 3rd power. Right, that's where that 3 is coming from. So yeah, hopefully you kind of see that relationship there. 3, a parent function y equals log of x was stretched horizontally by a factor of 100 to create a graph of f. Which of the following transformations on a parent function would produce the same? So if I've got a horizontal stretch by 100, horizontal is happening on the inside. Inside does the opposite of what we think it should do. So if I'm stretching by 100, that means I'm dividing by 100. And so then what they want you to see here is I have division in the argument. I can rewrite that as subtraction of the logs. And now then if I'm subtracting logs, log base 10 of 100. So this is 10 raised to what power is 100? Well, the answer to that log is 2. So this is the same as log of x minus 2. So a stretch horizontally by 100 is the same as a shift down 2. Just where they're coming up with that. And then 4, Chandler was asked to rewrite the logs and then simplify. Her work is shown. So she started with the correct answer here, or what she started with. She rewrote this as log base 2 of 32 plus log plus base 2 of 8 to the 3rd. That looks good. This was multiplication of the argument, so she rewrote that over addition. Log base 2 of 32, that's asking the question 2 raised to what power is 32? So that is 5. And then here, log base 2 of a to the 3rd. She just left that as is. Now then the 3 can be written out front as multiplication. That looks good to me. And so then she said 5 plus 3 log base 2 of a was 8 log base 2 of a because of 5 plus 3. That's not allowed. So that's where the mistake is made. Her first mistake is in step 4 when she combined terms that weren't like terms. Steps 1 through 3 are all correct. So a log is just like its own variable. Can't combine these because they're not like terms. So hopefully that one makes a little bit of sense. Okay, now I'm looking at 5.7. Check your understandings. So again, they want you to solve for x. So x is stuck in the argument. So I would rewrite this from logarithmic to exponential. So 49 raised to the 1/2 equals x. Well, 49 raised to the 1/2 is the square root of 49, which is 7. Here, before I can do anything, I need to isolate the exponential. So I would subtract 10 from both sides, which they have done. And now then, 6 raised to what power equals 36? So for me, like I said, you could probably figure that one out. I would rewrite 36 as 6 squared. And so 6 to the x equals 6 to the 2nd. And so x must equal 2. All right. Similarly here, isolate the exponential. So move the 5 over, it becomes negative. And so now then I've got e to the x plus 1 equals 15. So now then they're rewriting it from exponential to logarithmic. So this is log base e, which they wrote as natural log, of the answer, which is 15, equals the exponent, x plus 1. And now isolate the x, so subtract 1 from both sides. And so depending on if it's multiple choice, this is the exact answer. X equals the natural log of 15 minus 1. You can just leave it like that. Here they went ahead and simplified it and got an approximate answer by putting it in your calculator. But again, so depending on the situation, if it's multiple choice, you might have to do either one of these. But if it asks you for an exact answer, this is the exact answer. Just leave it. If it asks you to round to 3 decimal places, then I would have to go to the next step. But this is where I would stop. It's right here. So here I've got a natural log on both sides. It's a single logarithm. Drop the logs. Set the arguments equal and solve. All right, hopefully that one's easy. Here I can rewrite 8 as 2 to the third. And so now I've got exponentials with the same base. So drop the base and set the exponents equal. And then solve. Add 6. Square root. I chose to take a square root, so I must account for the plus or minus possibility here of 3. And now, if you'll remember, we had some problems at the end of class on Friday where we got 2 answers, but one of them wasn't valid. So think, could I plug these back in to make sure they work? So if I plug in a positive 3, 3 squared is 9, 9 minus 6 is 3. So 2 to the third is 8. That makes sense. What if I plug in a negative 3? Negative 3 squared is also 9. 9 minus 6 is 3. So remember, this is an exponential. And an exponential graph's domain is all real numbers. So you're not going to have as many errors as you would with like a logarithm. Because if you find the answer to a logarithm, remember there's a vertical asymptote. And its domain is only 0 to infinity. So just keep that in mind. If you're ever not sure, plug back in and see if it makes sense. All right, here we go, solving for x. So before I can do anything, I need to write the 2 logs on the left as a single logarithm. So because this has got a 2 out in front, I can't combine logs until they are naked. So I can't have any number in front of the log. So I could write that as an exponent of the argument, which they've done here. Now then, there's nothing in front of my logs. They're just being subtracted. So subtracting logs with the same base can be rewritten as division of the arguments, which is here. And now then, this will simplify. X to the second over x to the third is just 1 over x. And now then, I can rewrite it from logarithmic to exponential. So 4 raised to the first power equals 1 over x. And so then they solve that. They say x equals 1/4. So for me, I would, again, I don't do well with these fractions. So I would write that as 4 equals 1 over x, like this. And then I would put that over 1 and cross multiply, which tells me 4x equals 1. And then divide by 4. And so now I can see x equals 1/4. So 4, they're telling me to use my graphing calculator to solve. So if I want to know where does this equal this, remember we can just graph y equals both of those things. And then I'm looking for where they intersect. So hopefully you remember how to check the intersection. And you can find the intersect at x equals negative 0.427. In just a second, I want to solve this problem without using a graphing calculator. Because, again, I don't know what they're going to give you a calculator for and what they're not. But, I mean, I could see if you've got a calculator how that would be easy to solve. Just plug in and then use the intersect button. And then the last one, you're given a function and you're asked to find the inverse. So we rewrite f of x as y. Then we change the x and the y. Did they do that somewhere? No, they didn't yet. Okay, so that's not the way I would work 5. That's probably fine. I would go ahead and change the x and the y. So that would be 3 raised to the 4y minus 1 minus 5. And now then I'm going to try to get the y by itself. So then I would move the 5 over. So I've got the exponent. Sorry, I've got the power isolated. 3 raised to the 4y minus 1. So now then I could rewrite it from exponential to logarithmic. So this is a log base 3 of the answer equals the exponent. And so now that I move the 1 over, it becomes positive. So log base 3 of x plus 5 plus 1 equals 4y. And now then I would divide by 4. And so this would be I ran out of space. That would be the inverse. Log base 3 of x plus 5 plus 1 over 4. So again, they went ahead, they started moving stuff around before they switched the x and the y. Or actually, they never switched it. They just isolated for the x and then did it. That's not the way that I think about doing inverse. First thing I do, find the inverse. Change f of x to y, then change the y and x, which is what I did here, and then solve for your new y. And then rewrite it. So again, either method would work. Okay, I'm going to go ahead and work 4 without a graphing calculator on the next slide. Okay, so if I'm solving, I'm just trying to get x by itself. So we could divide by 6 to isolate the exponential. And that's an ugly number, 25 over 6. Just leave it. It's going to be 4 point something, 4.16, I think. 6 repeating. We can just leave it. And now then, rewrite it because my exponent is stuck. My variable is stuck in the exponent. So the way I can get it out of the exponent is to rewrite this as a logarithm. This is log base e, or natural log, of the answer equals the exponent, and then solve. So I would move the x over so it becomes positive, and then I would move the log over so it becomes negative. And that's an exact answer. So while they use a graphing calculator to do it, I want to show you that that's not the only way. Like, you could still find an answer algebraically. That you need to know both methods, I guess is my point. I just gave a whole big explanation and I never clicked record. So this one may be shorter because I'm kind of mad. You're going to get a worksheet where you're working through trying to isolate the variable for all these logarithms. And I'm going to also post the answers in a separate document for you to check your work. Just remember this. Whenever I solve for a logarithm, I always need to check if that variable, if that number that I found makes the argument negative. Because if the argument becomes negative, then it won't work. So the fancy word for that, or the proper word, is it's an extraneous solution. It's a solution that's not valid because it doesn't work in terms of the problem. So I also want you to remember this. Just because you find a negative answer doesn't mean that negative answer is wrong. You have to plug it in and see if it makes the argument negative. Because the deal is the argument can't be negative. And there may be some other transformations that have happened that makes the negative answer still work. So just always plug in both solutions and see if it makes the argument negative. Okay, I'm done. Go ahead and get started on that worksheet. And like I said, I'll have the answers posted for you to check your work.